So let's look at how the sender actually works on the transceiver. So the first steps that the code needs to do is read the serial input. Whatever you typed on that little serial window on the computer needs to be sent to the Arduino. We need to get it, and then what we're going to do with it is translate it to Morse code. To do this, we have a library, basically like a dictionary of each letter that translates to the Morse code equivalent. Then what we need to do is take care of an interesting problem with Morse code, which is each character is not the same length. So for example, E is only 1 dot, where some other characters might be 5 dots long or dashes. So we need to know exactly when it stops. So to do this, every time I read a letter from the serial input, I need to put the dots and dashes, but also make a sign that says this is the end of that letter. If you wouldn't do this, then it would be just a long streak of dots and dashes, and the Arduino would never know when to stop reading one letter. It wouldn't work. And the last thing you need to do is, it's great, now you have the Morse code. The problem is the Arduino cannot send the Morse code to the LED. The LED only does 2 things. It does high and low, on or off. So it's an interesting thing with all the machines. Basically, you need to translate what you want to do to the physical way of doing it. In our case, we need to transform the Morse code to the actual high and low of the LED. So this is what we do in the code. And then we just turn the LED on and off accordingly. So how does the receiver work? The way it operates is quite simple. The first thing we need to do is obviously read the photoresistor. We need to see how much light goes into it, right? So we're gonna read this. But there's an interesting challenge with doing so, and this applies to anything on the Arduino. The Arduino only does one thing at a time. It's a very tiny processor. So while you're looking at the photoresistor, you cannot be translating it to Morse code, you cannot be doing anything else. So the way you solve that issue on an Arduino, for example, is by doing everything very fast. You read the sensor, you translate whatever you have to translate, and then you go back to reading. And electronics is fast enough that it can do this in milliseconds. So even though the light is on for a short amount of time, it's going to be enough for the Arduino to loop once over it. We'll explain more in the future. The third step is we need to decide if it was a high or low. It's nice that we now know how much light hit the sensor, but is it a high? Is it a low? To decide this, we need to decide on a threshold. Basically, because it's an analog value, we're going to need to say this is an equivalent of a low, this is an equivalent of a high, and we pick the middle usually. And we say anything that's above that line, the threshold line, becomes a high. Anything under that line becomes a low, because we need to decide. And then we end up with something like this: a high and a low, or 3 highs and 1 low. We need to translate this back to Morse code. So, for example, in Morse code, 1 dot is a 1 high and 1 low. A dash is 3 highs and 1 low. So we need to translate that. When we have done so, it's nice, but we don't speak Morse code fluently. So what we need to do is translate it back to characters. So again, we use a dictionary inside of the code to translate those. And when all is done and good, we have the message now. So we need to display it back to the user. So the way we do this is by talking over a communication protocol called I2C. We talk to the display, the little LCD display, and we send the characters over to display to the user. At the same time, notice that over your serial connection, you also see both the Morse and the translated character over the serial connection. So we do both things. We send it to the screen and to your serial connection.